All right, so what's happening here is that a shell is launched from a certain point. You know the mass of the shell, I believe it's 12 kgs. And it's launched from a certain point with, you know what angle it's launched at and what the initial speed is. So those are known. And then when it gets to its highest point, this is where it explodes, right? So that's my explosion. And then it breaks up into two pieces. Both these pieces will be traveling horizontally because the velocity is horizontal at the highest point, as you know from projectile motion. So both of these pieces will be traveling horizontally. And okay, so that's what happens. The shell explodes. And the first question is asking, where is the center of mass of the two pieces going to be once they land, right? Now, for this, you don't have to know anything about the details of the two pieces. How would you find this very easily? How would you find the center of mass of the two pieces when they all land? How would you very easily find that based on what we just discussed?
You
Where
can
will
just
this?
find out where it
Yeah.
would land if it hadn't exploded.
Yes, exactly. Very good. That's exactly correct. Because the center of mass does not care about the explosion, right? The center of mass only responds to external forces. Explosions are always internal forces. So the center of mass, as we just discussed, will just proceed as if nothing happened. And magically the center of mass would end up exactly where the two pieces, where the original bomb would have ended up if it had not exploded. So this is where the center of mass will be. And you know how to find the range of a projectile. We did that a long time back in chapter 3. And if you look back to your notes for chapter 3, you know that if an object lands at the same height that it was launched from, then the horizontal distance that it covers is given by a formula like this, v0 squared divided by g sine of 2 theta. We had derived this back in chapter 3. And so that would be the answer. So that would be the x center of mass would be that. That makes sense? So you didn't even need to know the details of where the two pieces are or what velocities they took off with or anything, because you know that regardless of those details, the center of mass would proceed as if the bomb had not exploded. That's a very important insight here. And then the next thing is, the next part of the problem is asking if you're given the final location of one of the fragments, and you want to find out where is the other fragment located. So if the heavier fragment lands back at the same point from which the shell was launched, the most useless bomb in history, it breaks up into two pieces, and one piece comes back and obliterates the people that launched it. Where will the lighter fragment land? All right, so okay, so we are told, so we can easily find the masses of the two pieces. We are told that one of them is 5 times as heavy as the other. So if the total is 12, one of them must be 2 kgs and the other one must be 10 kgs. I mean, the way you would find this is if you can assume the smaller piece is m kgs and the larger piece is 5 m kgs, because you're told that one of them is 5 times as heavy as the other. And so 5m plus m must be 12. And so from there you can solve that m is 2 and 5m must be 10. All right, know the masses of the two pieces. So the final situation looks like this. The heavy mass has now ended up at the starting location. So the 10 kg piece is located over here. And the light piece is and this, we know where the center of mass is located. So I'll just mark that as well. So let's say the center of mass is located over here. There is nothing at the center of mass. It's just a position marker. And the lighter piece has ended up somewhere over here, let's say. So the 2 kg is sitting somewhere over here, right? And you already know where the center of mass of these two pieces is located. So now you can easily find, so this is at 0, 0. This is at our XCM0. We've already found the XCM. And this is at some unknown X0, right? And so now you can use the center of mass formula to find out the unknown X, the position of that lighter piece. So, so you know that the one-dimensional position of the center of mass formula for X is m1 x1 plus m2 x2 plus m3 x3, but we only have two masses here divided by m1 plus m2. And so you know xcm, we've already found that. You know x1, that's 0, right? You know both m1 and m2. And so the only thing that you don't know is x2, which is this x. And so you can just solve for x. That clear now? So knowing the position of the center of mass, which you can find quite easily, you can easily find the position of one of the masses if you know the position of the other one. Right? So you did not need to use the techniques of projectile motion to figure out what velocity did this 2 kg mass take off from and how much time is it going to, so where is it going to land up. So you could have done the problem like that as well, but this method is much easier.